going to talk about the Quality Control Quality Assurance Program and Asphalt Acceptance, Chapter 7 of the ICAT training program. My name is Nathan Awad. I am the asphalt engineer for the Indiana Department of Transportation. Design mix formulas, or DMFs, are the asphalt recipes, if you will. They shall be in accordance with 40105, 40205, or 41005 of the specifications. DMFs must come from an approved mix design laboratory, and all the mix must be produced at a INDOT certified plant. And these DMFs are submitted online through an online system called DMF Entry. Here is an example of a DMF that has been submitted on DMF Entry. You can see at the top, here are all the raw aggregates that are proportioned into the mix. There's other things in the mix design, such as type of PG binder and where it's coming from. The mixture designation, the percent recycled asphalt shingles, binder replacement, the percent virgin binder, wrap, binder content, PVE. The DMF also contains things such as the design gradation compared to the specification requirements, the blended aggregate GSP and corresponding absorption, other important things such as the mass of the gyratory pill, the max, the bulk specific gravity of the mix, design air voids, BMA, dust to binder ratio, and other things important for future reference. As alluded to before, there are three main HMA specifications: 401, 402, and 410. 401 is most of the quality control, quality assurance HMA, which includes dense graded and open graded material. This is material accepted based on test results. 402 is typically referred to as 402 mix or certification mix. This is mix that is accepted on certification with test results from the producer. And then 410 is SMA pavement or stone matrix asphalt. So asphalt is divided into lots and sublots. So let's first look at dense graded HMA in the 401 section. Base and intermediate is defined as, a lot is defined as 5,000 tons, and a lot has 5 sublots. So a sublot is 1,000 tons. For surface, a lot is defined as 3,000 tons, and again there are 5 sublots in a lot. So a sublot is 600 tons. For stone matrix asphalt SMA, lots and sublots are a little different. A lot is defined as 4,000 tons, but there are only 4 sublots in a lot. So the sublot is still 1,000 tons for intermediate. For surface, a lot is defined as 2,400 tons, but there are 4 sublots, so that equals 600 tons in a sublot. So dense graded HMA and SMA, a sublot for intermediate is 1,000 and a sublot for surface is 600. The only difference is you have to remember HMA has 5 sublots in a lot and SMA has 4 sublots in a lot. For the rest of this presentation, we are going to look at how different mixes are accepted in different ways. 401 mix that is less than a lot it's accepted by single sublot. just test results in that sublot. 401 mix is also accepted by lot. So if there is a lot of material, we accept it by PWL, percent within limits. This is based on test results, but also brings in statistics with how consistent the mix is. 410 SMA is accepted by adjustment points, and open graded is a variation of single sublot acceptance. And then as mentioned before, we do 402 mix, which is accepted by certification. So we'll look at these more in depth one by one. No matter the type of acceptance we are using to accept a mix, it's all based on test results. And these test results come from an acceptance sample. So we get plate samples and cores from the pavement in accordance with ITM 802 and ITM 580. The engineer randomly selects a location within each sublot and obtains plate samples and cores. NDOT takes possession of those samples. So let's begin looking at 401 mix single sublot acceptance. Here are pictures from the actual specification book regarding single sublot acceptance. As you can see, these can be very confusing. For example, volume of binder effective. If it's greater than or equal to 2 plus 2.0 and less than 2.5 from the spec minimum, the payment is 1.05 minus 0.01 for each 0.1% above 2.0%. That is very difficult to understand. So here's an example of the air void pay factor table, and I've converted it into a lookup table that makes it much easier to determine pay factors. And I would earmark this part in your manual for use later on the exam. So for example, if air voids were calculated as 3.9%, the pay factor for air voids would be 1.00. Here is a lookup table for volume of effective binder. And this is based on deviation from spec minimum. So spec minimum is also in the specs. So what would be the pay factor for a 9.5 millimeter mix at 13.2% VBE? We would first look at 9.5% or 9.5 millimeter mix. The minimum is 11%. So we can see that a 13.2 VBE is 2.2 above spec minimum. .2 spec minimum equates to above spec minimum equates to 1.03. So here is a lookup table for density. So for example, what would the pay factor be for a density of 91.7%? You can see here it equates to a pay factor of 0.92. In order to calculate pay for single sublot, we need to determine the sublot composite pay factor. Per specification, the air voids are worth 30%, the VBE is worth 35%, and the density is worth 35%. So for this example, let's look at a 9.5 millimeter surface, and let's look at sublot 3. These are test results we obtained from the laboratory testing, and we calculated 4.99% air voids, a VBE of 12.97, and density of 93.0. So using air voids of 4.99%, VBE of 12.97, and density of 93%, we need to figure out the corresponding pay factors. Using the previous tables, an air void of 4.99 would result in a pay factor for the voids of 1.05. A VBE of 12.97 would result in a 1.05 pay factor for VBE, and the density pay factor would be 1.00. Thus, the sublot composite pay factor would equal 1.033, and you would round that to 1.03. So how do we turn that sublot composite pay factor into a dollar amount for a quality adjustment? You use this equation, where L is your sublot quantity, U is your unit price, your sublot composite pay factor, and your mixture adjustment factor. What is this? We'll look really quick into what this mixture adjustment factor is. So the mixture adjustment factor, it's going to look like a lot of confusing equations, and don't worry about it too much for the exam. I just wanted to make you aware of what it is. The bottom line is that some mixes are heavier than others based on the aggregate. So if you have a heavy mix, NDOT accepts HMA or pays for HMA by the ton. So if you have a heavier mix, even though we're paying by the ton, and you would say we paid for 1,000 tons of mix, it actually would not go as far as a mix that weighed less. So it's all about trying to get the payment for the asphalt back into a normalized tonnage, so that we're not short or over on material. So this is how it's calculated. It's using the DMF, GMM, and some constants in an equation, and you don't need to understand the math right now. It's not going to be on the exam, but it is calculated a certain way, and then based on that calculation, you determine the mixture adjustment factor. So for this example, let's just say the MAF turned out to be 1.012. So let's calculate the quality adjustment. So let's assume that we have 600 tons of material and that it was $74 a ton. We previously calculated the sublot composite pay factor as 1.03, and we just saw the MAF was 1.012. So if you calculate the quality adjustment, it comes out to be, for this sublot, a bonus of $1,316.21. Now, for example, without the MAF, it would have come out to $1,332. So NDOT would have paid more for this mix, even though it didn't give us extra coverage or extra lane miles. So that's what the MAF does. It adjusts the tonnage to correct for heavier or lighter mixes. So we accept a full lot of material, or 5 sublots, by PWL, percent within limits. It not only looks at test results and how close it matches specification, but also how consistent those sublots are to each other. So it brings in statistics into the acceptance program. So it's a more discerning quality measure because it captures the mean and standard deviation and encourages uniformity. So for example, if you have 5 sublots, and let's say we're targeting 4, the number 4. If 1 is 2, 1 is 6, 1 is 2, 1 is 6, and the 5th sublot is 4, they all average 4. If you're just looking at average or mean, it seems like the mix is perfect. But if you look at consistency, it's varying a lot. So bringing PWL into that would show that that's not actually a very good mix, because it's all over the place. So that's how percent within limit works, and we'll look a little more into that. So accepting by PWL, we still use the same volumetric equations we're used to. And like I said, it brings in the average of those tests and also looks at the standard deviation. Before we can calculate a quality adjustment by PWL, we need to know the specification limits. And these are contained in 401.19 of the spec book. For air voids, the lower specification limit is 3.6 and the upper specification limit is 6.4. If you notice, 5% is right in the middle of that. VBE is a little different. Remember before we looked, it's spec minimum and spec plus 2.5. So for example, if we're looking at 9.5 millimeter, the spec minimum would be 11%. So the lower spec limit would be 11 and the upper spec limit would be 13.5. And with density, we are only concerned about a lower spec limit, which in this case is 93. So let's look at some test results. Assume all these test results are given to you for 5 sublots, or a full lot of material. We are looking at a 9.5 millimeter surface, and we want to calculate the average and the standard deviation. Now, you can do this with a calculator, and you can even calculate standard deviation with a calculator, but you will not need to on the exam. So what do we do with the average and the standard deviation? So we need to use these values and the corresponding specification limits in yellow to calculate the PWL. Now, don't get too concerned about the math, but be aware this is how it's calculated. These averages go into the QU and the QL, which then correspond to a PWL upper and a PWL lower. These are then combined to come up with a total PWL. And again, don't get too worried about the math, because the total PWL will be given to you on the exam. Just be aware this is how it's calculated. So if we have a PWL, we then want to calculate the pay factor that corresponds with that PWL. How do we fill out this table now that we have the PWL? Again, we have some very confusing equations that correspond to the graph on the right. And to make it easy for you, again, they have been converted into a lookup table. So for instance, a PWL of 72 would correlate to a pay factor of 0.93. So let's begin filling out the table. A PWL of 72 corresponds to 0.93 pay factor. Likewise, a PWL of 99 corresponds to 1.05. A PWL of 58 corresponds to 0.82. Now, just like a sublot composite pay factor, a lot composite pay factor is made up of 30% of the air void pay factor, 35% of the VBE pay factor, and 35% of the density pay factor. Now, I've shown intermediate steps here, but this could all be done with one calculation. So 0.3 for your air voids times 0.93 plus 1.05 times 0.35 plus 0.82 times 0.35 will give you a lot composite pay factor of 0.93. So how do we turn that lot composite pay factor into a quality adjustment in dollars? Just like a sublot composite pay factor, there is a quality adjustment equation for a lot composite pay factor involving the lot quantity, the unit price, and the lot composite pay factor. So for this example, remember we're talking about surface, so 3,000 tons times $74 a ton times our lot composite pay factor of 0.93 minus 1 divided by our MAF, again that we are is a given. That calculates to negative $15,355.73. So that is a credit to the contract, or a penalty, if you will, because the test results and PWL were marginal. So there is a negative pay factor there, or negative dollar amount. Like everything else, there's an app for that. So we have HMA Pay Wizard. It's an online cloud-based program where test results all are automatically uploaded, and lot tonnages and QA adjustments and all that is automatically calculated. So you can see here's all our test results. Averages are calculated, standard deviation, the QU and the QL all are used to calculate a total PWL, which all correspond to an air void pay factor, a VBE pay factor, and a density pay factor, which then go into a lot composite pay factor. In this case, there is a bonus of $4,590. So we looked at 401 single sublot and PWL acceptance. Now we're going to look at 410 or stone matrix asphalt, SMA, which is accepted by adjustment points. And those adjustment points are calculated on three main properties: aggregate gradation, how close it is to the DMF, binder content, and density in the field. So SMA adjustment points, those specifications are in 410.19, and again, they are slightly confusing based on gradation, density, and binder content. And so don't get too worried about these tables and what they mean. We're only going to look at how to calculate the final quality adjustment. So the quality adjustment equation for SMA looks similar to PWL or single sublot quality adjustments, but it's slightly different. It involves the lot quantity, the unit price, and then P, which is the total adjustment points. So let's work through this example of SMA. So let's assume there are 4 600-ton sublots, or 2,400 tons. The unit price was $69 a ton, and the MAF was 1.124. We've already calculated the total adjustment points of 4.0. So we take those givens and our calculated adjustment points and put them into the quality adjustment equation. 2,400 tons times $69 times 4 times 4.0 divided by 100 over 1.124. the quality adjustment would calculate to 5,893.24. Now, it's important to note that SMA does not have bonuses. So a quality adjustment that is calculated means it is going back into the contract or is not going to the producer. So the way we accept or calculate adjustment points and quality adjustments currently is with an Excel workbook. We are working on getting that incorporated into our HMA Pay Wizard program, but for right now, there's an Excel workbook that does all these calculations for you. As you can see here, here's your 4 sublots, your gradation, and measured binder content. And here's where you calculate your density, and then it spits out adjustment points based on those test results. So like in the example we were looking at, 4 adjustment points equates to a credit to the contract of $5,893.24. We also have a mix called open graded mix, and it's similar to single sublot acceptance, only that the sublot composite pay factor equation is a little different because we pay on binder and air voids only. So don't worry about how it's calculated. It is in the specifications. But for example, let's pretend we had a binder pay factor of 1.04 and an air void pay factor of 1. You simply do the equation and get a sublot composite pay factor of 1.008, which rounds to 1.01. And we have an Excel workbook for that. So for instance, here's a sublot of open graded with the corresponding test results, and it calculates air voids and binder and pops out a sublot composite pay factor and quality adjustment. So in this case, that is a bonus to the contractor because it's above 1% pay sublot composite pay factor. Lastly, I wanted to mention 402 mix or certification mix. So for mixtures where there is original contract pay item quantities less than 300 tons, we accept that in accordance with 40209, which is by Type D certification. Basically, if there is less than 300 tons on the contract, that's not enough mix for us to be able to get a viable test in order to run and see what those test results are. It's not enough mix. So what we do is we require a certification from the producer where they've done quality control test at their plant and assure us that the mix meets specifications. And air voids tolerance shall be plus or minus 2.0 from the design, and binder content shall be plus or minus 0.7% from the design. Here's an example of a Type D certification that shows where it's coming from, what job it's going to. Here is the design air voids and the tested air voids. Here is the design binder content and the tested binder content. These do meet the prescribed tolerances, and it is signed off that the mix is within specification. So we have looked at the quality control, quality assurance program and the different ways we accept asphalt based on type and quantity. I strongly suggest that you become familiar with calculating quality adjustments for single sublot, PWL, and the like. And please practice on the homework problems and the classroom problem packet. And I think you'll do just fine on the exam. Thank you.